This video is based on to and fro motion when the starting and ending point themselves are not fixed. They are moving. Pause and go through this question and then proceed. Okay, so these two cars are moving towards each other. They are coming from a distance of 560 kilometers. They are moving towards each other. And there is this pigeon who is flying to and fro from one car to another till the point these two cars meet. So this is the motion of the pigeon. This is the to and fro motion of the pigeon. And we have to find distance traveled by this bird. This total distance from here till here, this distance traveled by this bird. So distance between the two cars, the distance that two cars together travel is 560 kilometer. And relative speed of the two car would be 30 plus 40, that is 70 kilometer per hour. As the two cars are coming towards each other, relative speed would be sum of individual speeds. So total time taken by the cars to meet would be this distance 560 that they travel to meet upon their relative speed is 70. This would be 8 hours. Now in these 8 hours, the pigeon is continuously flying from one end to another, from one car to another. Distance covered by the bird would be the speed of bird, that is 90 km per hour, into the time for which the bird is flying, that is 8. 90 into 8 is 720 kilometers, the distance for which the bird flies. This question can also be solved by finding these individual distances from here till here, then from here till here. We can add up these distances and find the total distance. Okay, we can find these individual distances, then we can spot a pattern in them and we can find the sum of the progression so formed. That would be the total distance. But this, what we did, is definitely the easier method. Next question. Pause and read. Okay, so a thief escapes from the jail and after some time a police and a dog start chasing him. Dog, being the faster, runs to and fro between the thief and the policeman till the time the thief gets caught. And we have to find the distance traveled by the dog in the direction of the thief. This is important, in the direction of the thief. So here these red lines show the motion of the dog, okay, whereas these blue lines will represent the movement of the policeman. Let me expand this further. Okay, here the dog runs forward towards the thief, meets the thief at this point and will return. Meanwhile, the police is also running towards the thief. Dog and the police will meet again at this point and dog will return towards the thief. Dog will meet the thief at this point and will return towards the policeman, meeting him at this point. Like this, the to and fro motion of dog will continue. Here, the starting and the ending points are moving. We have to find the distance traveled by the dog in the direction of the thief. That means only the distance traveled forward will be counted. Okay, this is distance traveled forward. This is distance traveled forward. This is distance traveled forward. We will have to ignore distance traveled backward. Okay, this is distance traveled backward. This would be backward. So we have to find the total distance traveled forward. Let's solve this. Thief leaves 5 minutes before the policeman. Okay, this is given in the question. Thief leaves 5 minutes before the policeman. So in those 5 minutes, he will cover a distance equal to speed of thief, that is 40, into 5 minutes. This is 200 meters. So when the chase begins, thief is already 200 meters away from the policeman. The distance between them is 200 meters. The relative speed of the police and the thief would be, relative speed would be speed of police, that is 50, minus speed of thief, that is 40, 10 meter per minute. These speeds are subtracted as they are running in the same direction. So time taken to meet will be initial distance 200 meters upon the relative speed, that is 10. This is 20 minutes. So from the beginning of the chase till the thief gets caught, the total time gone by is 20 minutes. And in these 20 minutes, the dog is continuously running. So total distance covered by the dog is speed of dog, that is 60, into time, that is 20. Total distance is 1200 meters. This total distance is equal to distance forward plus distance backward. Distance covered by the dog forward plus distance covered backward. And distance forward is what we are asked in the question. Now if I just focus on this one round made by the dog, this one round of distance forward and backward, okay. So from here till here, this point, this distance is distance forward, and from this point till this point is distance backward, okay. Sum of all these forward distances would be distance forward, and sum of all these backward distances would be distance backward. And this line represents distance travelled by the policeman. So we can say that distance forward is equal to distance travelled by the policeman plus distance backward, okay. This we can see from here. Distance forward is equal to distance travelled backward plus distance travelled by the policeman. So this here is equation 1. This we have is equation 2. And equation 3 would be distance travelled by the policeman is equal to speed of policeman, that is 50, into time for which the policeman was running, that is 20 minutes. This will come out to be 1000 meters. So this is equation 3. Now we can use equation 1, 2 and 3 and calculate distance forward. I am writing equation 2 again. Distance forward is equal to distance travelled by the policeman, that is 1000 meters, plus distance backward. And distance backward is what? 1200 minus distance forward. This is 1200 minus distance forward. So from here we can say 2 times distance forward is equal to 2200, or distance forward is equal to 1100 meters. Put this in this equation number 1 and distance backward will come out to be 100 meters. So this is how we work out the to and fro movement when the end points are moving. Thank you.